Okay, hello everybody. Hey. All right, how awake are you? Yeah? Cool. All right. If you need to be more awake, there will be chocolates. They may be given out to people. Okay? So you have stuff to look forward to. I'm Zainab. I really love Lambda World. I've been here for quite a few years now, so you may have seen me before. I'm also on the program committee, which means that I really, really want to encourage you guys to come again. And I know that Lewis said yesterday, like, we don't have friends. We do have friends, right? We do have friends, so we can invite our friends, and hopefully next year you guys will all be here as well with friends, enjoying the beach, and enjoying the really great functional programming talks. So there's kind of been a theme, I think, this year of trying to grow the functional programming community, right? Trying to encourage new people into the community who haven't had much experience with functional programming or functional ways of thinking before. And that's something that I'm really interested in as well. So I'm a functional programming trainer. What that means is that I really like giving workshops. I really like going and speaking to people who are doing not necessarily functional programming, they might be doing other languages, and trying to show them how functional programming can help them in their jobs. There we go. And so what I'm going to talk to you about today is a kind of a project that is in the functional Scala ecosystem, and specifically in the stream processing ecosystem, on trying to get people to understand streams better. And it's known as Aquascape. I wrote it, so it's my thing. Weird things are happening. There we go. Okay. All right. So stream processing. Who here does any stream processing? Okay. Maybe like more than half? Okay. Who here thinks they actually know what stream processing is? Like, yeah, less, right? So we use this term, right? And if someone were to ask you, like, what is a stream? You know, like the big flowy thing, right? You can probably go outside, go hiking and find one. But actually, a stream in code is a very different thing. And it's kind of this bucket of problems. You might encounter stream processing if, for instance, you're doing stuff with data. Who does lots of data processing? Yeah, some, okay. Or if you have event-driven architectures and you're doing stuff with events. Who does lots of that? Yeah, that's my category. And these two things, you know, data processing and event processing, they seem very different, but they actually have lots of really similar concerns. So they have a load of related problems associated with them. Like, for instance, let's say that you're doing stuff with data, you're processing huge amounts of data, maybe infinite data. You need to somehow deal with that. Or if you have an event-based system, you might be processing, you'll be receiving events. You don't know when they're going to happen, right? They might be happening at any point in time, sometime in the future, and your application might run indefinitely. That's kind of an infinity-like thing too, right? So they both have this concept of infinity. Let's say you're doing stuff with data, you're probably going to be doing a load of I.O., right? You're going to be doing stuff with networks, stuff with files, so you've got to deal with I.O. With I.O. comes errors, as we know, right? Like, we have to handle errors. With I.O. comes resource management as well, right? You're opening files, you need to close files, right, at the end of your program. And often when we have these applications, we want to do multiple things at once, so we end up doing things concurrently, right? And concurrency is like a really difficult ballgame in itself. So we have all these related concerns. And they have other stuff that's also challenging and challenges associated with them. Like, for instance, you've got a really complex event-driven system with lots and lots of stuff going through. You might have back pressure problems. Those might have bottlenecks associated with them. If you're doing stuff with concurrency, you might end up the horror of race conditions, right? So they have lots and lots of similar problems. So we kind of take all of these things, right? Seemingly unrelated things, and we put them in a big bucket, and we call it a stream processing problem. And when we have a stream processing problem, we look for stream processing solutions. I'm going to be talking to you about a particular solution today, which is in Scala, called FS2. Okay, how many people are Scala devs, just to get a rough understanding? Okay, that's cool. Maybe I should have asked the reverse. How many of you are not Scala devs? Like, you don't do Scala. Okay, you're still in the right talk. Okay, because even if you don't do any Scala, I reckon that you'll learn a lot about how you can apply stream processing in other languages as well. Okay, so FS2 stands for Functional Streams for Scala. It is a stream processing library in the Scala ecosystem. It's one of the first libraries I actually started using when I was using Scala way back when. I wanted to do some stream processing for a game engine. And I came across this one, and I just kind of fell in love with it. And so since then, throughout the years, I've been contributing to FS2, contributing to lots of libraries around FS2, and really enjoy it. Okay, so what is this thing? What is FS2, functional streams? So a stream is a way of expressing a problem, right? The way that this library FS2 lets you express that problem is that it gives you this stream data type, stream, and it gives you a load of operators for manipulating that stream. So for instance, you might have an operator called repeat, which will just repeat the stream, and it will do that up to infinity. Or you might have an operator that will help you evaluate side effects, such as eval map. We'll see that one. And there's an operator for concurrency, merge. If I were to write down all of the operators that exist in FS2, you would not be able to read this slide. There are tons and tons and tons for doing practically anything, and you can also write your own. So it's actually kind of overwhelming, right, the amount of stuff that FS2 gives you. Okay, so we're going to take a look at a stream processing problem, and we're going to take a look at one in FS2. And to help us explore the problem space, we are going to have some of my favorite cats. On the left here is Popcorn. Oh, wait, where's she's gone? No. There, okay. This is Popcorn. She's very cute, right? She's not my cat. She's my friend's cat. On the right here, left, right, anyway, that side, that is Mao. If you've ever been on video calls with me, or if you've seen me speak when I'm doing remote talks, he will always be there. He will always be there. He loves cuddles. And this is me. As I said, I'm a functional programming trainer, and I really like teaching FS2. Okay, so how are our kitties going to help us explore this problem? We're going to explore the life of cats, right? The life of cats as a stream. Right? Very, very simple problem. So cats, if you're familiar with them, they do kind of two things. They eat their cat food, and then they go to sleep. And then they wake up again, and if they're kind of an old kitty, they'll just eat their cat food, and then they'll go to sleep again. And this will continue in quite a routine way. Okay, so we're going to try and model this in some code. In Scala, to model this in code, we're going to use an IO monad. What we're going to do is that we're going to, when a cat eats, print that cat's name with a little tin can to represent cat food. There's a reason why we're using a red tin can to represent cat food. And then when the cat naps, we're going to assume that cats, right? Cats sleep in boxes, right? If you've watched YouTube videos of cats, they're always like, cat in box, right? Cat in box. Cats love boxes. So the cat is going to sleep in the box. So when the cat naps, we're going to print the cat with a box. And then we're going to return at the end a string, which is the cat and box concatenated. Okay, so if I were, for instance, to call the function eat with the cat mao, and I were to evaluate this, I would get mao with a little tin can of cat food. Okay, so eating and napping. That's what cats do, right? So we have our two cats, we have Mao and we have Popcorn, and they eat, and then they nap, and then they do this, like forever. Okay. So imagine you've got this code. It is in FS2, it compiles, it runs. What does it output? Oh, I'm going to give you some options. Okay. Option 1, we get Mao with the napping box, and then Mao with the napping box and the can of food, and then Popcorn with the napping box, so Popcorn goes to sleep, and then Popcorn with the napping box and can of food. Who thinks that's what it'll output when we run this? Oh no, we're getting lots of shakings of heads. Okay, so some people, they've had their coffee. All right. That's option 1. Option 2, okay, Mao, can of cat food, then Mao, can of cat food and box, because he goes to sleep, right? And then Popcorn, can of cat food, and then Popcorn, can of cat food and box. Is that going to happen? Who thinks? Okay, no, we're not sure. We think no. Okay, there's another option, right? So there's Mao, cat food, Popcorn, cat food, right? Mao, cat food and napping box, and then Popcorn, cat food and napping box. Who thinks this one? All right, yeah, few hands. Okay, it has to be one of them, right? Like, does it? There is actually another option, right, when we're dealing with stream processing, which is that maybe we have no idea. Maybe it's non-deterministic. Maybe each time we run this, we're going to get something else. So I'm not going to tell you the answer, by the way. This is just to illustrate that we have a group of Scala developers here. A lot of you have actually used FS2. And this is some really simple code. And we can't predict the output. And we are using this library and we are writing lots of applications with it, in which maybe it is important to kind of know what's happening, right? So this is a bit of a problem. It's not just a problem, by the way, with FS2. I really love this library. It's a good one. It is a problem with stream processing in general, right? It's such a complex space that when you're trying to express solutions in this space, you do end up being very confused. Okay, so I think we can do better, right? I think this is one of the reasons why functional programming is a little bit difficult to people who are outside the space, right? They see this code, it might be very short, right? We're usually really proud of how short our code is, but it's pretty difficult to understand. So I went and had a look outside the space of functional programming at other stream processing frameworks, and to see, like, are they more friendly? And I found one which is called RX observables. Who's used RX observables in JavaScript? No? A few people, yeah, okay. Maybe some of you might recognize what this thing is. Do you recognize this diagram? So, okay, yes, some nods, right? Okay, this thing, okay, this is called a marble diagram. What it is that it's a way of explaining how an operator in the RX observable space, which is a stream processing space, works. It's trying to explain how take two works. So you have a stream of stuff, and you take two of that stream, and this is what you get. Okay? And this is in the JavaScript space. You can actually go to a website, and you don't need to do anything except like plonk this URL in your browser, and you will be able to play around with these diagrams, right? No downloading anything, no even needing to like run any JavaScript because it's all doing it for you. And then you can learn how these operators work. And that's really cool. That's really friendly, isn't it? It would be really nice if we could have something like that for our functional libraries. Okay, so that's what we're going to try and do today. First of all, in order to explain how this library works, we need to develop a mental model for it. So we're going to develop a mental model for stream processing. And then we're going to see if we can draw that model. So make a nice picture, right, which shows how the stream works. And then we're going to make this interactive, because that diagram that we saw before, right, the marble diagram, we could actually go and drag and drop stuff. It was very fun to do. Okay. That's a lot of stuff. We can get there. So the mental model, let's have a look at the code that we just saw. So we have a stream of Mao and popcorn. We eval map eat, they eat something. We eval map nap, they nap. The way to kind of understand this stream is something that there's a model that was kind of developed over several years, actually, with me teaching FS2 to a few people. I know a few people in the audience who've actually been taught FS2, so who've kind of helped develop this model. It's called the stage model. Okay, and this is how we should think about streams, right? So you can think of this stream as being made of 3 stages. It's composed of the stages. We'll call the first stage cat names, the second stage eat, and the last stage nap. And the way that our stream operates is that a stage will pull on the stage above, where pull means request an element. You can think of it like so, but more like in a synchronous way. And when that stage goes and pulls an element and it gets an element back, it can then decide what it's going to do with that element, and it can output that element downstream. Of course, it would be great to explain this with a diagram, which we don't have yet. So instead, I have chocolates, and I would love to bring Mao and popcorn, right? I would love to bring the kitties on stage. Unfortunately, I can't. They don't like traveling. So instead, we're going to represent the kitties. So Mao is a black cat, right? I have black, Lindt, dark chocolate. Okay, so this is Mao. And I've got white, dark chocolate. Oh, wait, white, dark chocolate? White chocolate. This is popcorn. Popcorn is a pale kitty, pale blonde kitty. And I'm going to need audience participation. I'm going to need 2 volunteers. You will get chocolates. Please. Come on. No one? Come on. Okay, cool. All right. Thank you so much. By the way, no one has been primed except for me, so they don't know what they're doing.
I only had chocolate.
Okay, so I would like you to stand, one of you here, okay, and one of you here, and I'm going to be here. And we are going to represent the stages. Okay, there are 3 stages. Okay, Carolyn, please represent the nap stage. Okay, remember that we said that cats nap in boxes? Boxes are brown? Brown, right? It kind of fits. Okay, and would you like to represent the eat stage?
I sure would.
Okay, red tin of cat food. Okay, red. Okay, and we're building strings of Mao and popcorn, and we're going to append. So, okay. The way that streams work is that we start with the downstream stage, which is Carolyn. And what you are going to need to do is do something called a pull. And the way that I want you to represent a pull is to go like this to Wendy. Okay? All right. Now, Wendy, you're the eat stage. You're going to pull. So pull on me. So do the gesture. Yeah. Okay, cool. And I'm the cat name stage, right? I have Mao and popcorn. Okay. Mao is my first element, and I'm going to output. Okay. And now Mao eats, which means that you're responsible for the eating. Don't eat the chocolate. But take one of your red cans of food, yep, and hand the red can of food plus Mao, which is this one, to Carolyn. Okay, so you're going to do the output. So she's outputting, right? Okay? And then you've got that, and then you've got the nap, right? And then what does the last stage do? Right? Well, this is a Scala program. Okay, we're not doing anything with the output, so it gets garbage collected. So we'll need some more people to be the garbage collector. Okay, so do you want to go hand some chocolates out to the garbage collection? Or you come collect. Yeah, come collect.
Shall I throw?
I feel like the health and safety, I don't know if I like, yeah, 3 actually, 3. So you take a nap one. Okay? Okay? Cool. All right. And then...
Yeah, very late.
Okay.
Lost those chocolates forever.
That's okay. That's okay. They've been garbage collected. They will go, in a bin of sorts. Okay, and now this process repeats. So do you want to pull again, Caroline? Okay, and you pull. Okay, and I've got this, and I output. Yeah. Yeah. Cool. Okay, and now you're actually going to pull again. So pull, pull. And I don't have anything, right? So I'm going to say that I am done. And I'm just going to give you a thumbs up. So I'm done. And now you, Wendy, need to tell Caroline that you're done. Okay? We're all done. And actually, we all go and get garbage collected at this point because the program finishes. All right, so thank you very much. That was amazing. Okay, so... All right, so why is it not on the screen? It's gone. There we go. Okay. Okay, so that wake you up, right? Like chocolates. Let's ask the question again, right? So we had this stream. Should we see what happens? Like, okay, it was Mao and Popcorn. They ate, they napped. Who thinks 1? There's still no ones? Okay, who thinks 2? Yeah, more 2. Yeah, cool. So now we kind of understand a little bit more about how our stream works through that live reenactment of streams, okay? That was amazing. Wouldn't it be great, right, if each time we were struggling with some code, we were looking at some functional stream code, and we thought, oh, this is hard. Come on, let's get up. Get all your friends together, get some chocolates, and let's just pass them around, right? Like that's going to work every time, right? Yeah, if that was the way that we coded, we'd be very happy, right, and fulfilled in our lives, but it might take a little bit more time to understand things. So it would be great if we had some kind of a programmatic way to explain this code. Maybe something like a diagram, but something like a diagram that we could generate. Okay, so this is another way of representing what just happened on stage, right? Instead of having people doing actions, we just got a list of text, right? Each of these things is an instruction, okay? We had, for instance, nap pulled on eat. Eat pulls on cat names. That was cat names, right? And then instructions for outputting and instructions for pulling and evaluating. So this is a lot harder to actually understand, right? But it's the same thing. Wouldn't it be nice if we could just generate this, right? Generate this from our stream somehow. And it turns out we can. But in order to do so, we need to learn a little bit more about what happens under the hood when we have this functional stream. So there's actually another model which you learn when you're actually working with FS2 and you're developing the internals of FS2. It's called the pull model. So if you were to go and look in the FS2 codebase, you'd actually find that every single operator is built using a few primitives. And they're assembled in this structure, which is known as a free monad. Some of you may have heard of free monads before, some of you may not. If you haven't, I encourage you to check out previous talks at Lambda World. There are tons. And for today, though, we're just going to take a look at these instructions. So one of those instructions is a pull instruction. It's called uncons1. Uncons is kind of like working with lists, right? So you call it uncons. There's an output instruction. Output 1, so that was, giving the chocolate out. And there's a done instruction to say, I'm finished, I don't have anything left. And so when we're writing operators within FS2, we're actually just putting all of these instructions together. So for any operator, for some kind of operator, first we'll probably pull an element, right? Then if we get that element, we'll do some evaluation and we'll output that element because, you know, we only pulled because we pulled on, right? So we have something to output. Or we may be done, and so we say we're done. Okay, so this is how you write an operator in FS2. This is actually also exposed to you if you're using FS2, so you can go and write your own custom operators, right? It's not just internal. So we can actually make use of that to just write our own operator, because all we need to do is to print between each of these steps. Okay, so before I do my unconsing, my pulling, I'm going to print pulling on, and I'm going to label this operator with some stage name, right? We had names like cat names, eat, nap. Okay, so we print before we pull. When we get an element before we output, let's print that we're outputting. So we just print, okay, outputting from a stage. And then when we're done, let's print that we're done. So you can actually go and you can write this code. This isn't FS2 internal code. Okay, now if we do that, we have this stage operator. And we can actually just have it as an extension method on our stream. So we can just take our stream and call .stage. And now, when we run our stream, we'll also run those print statements. So if I were to run this stream, I would get this. That's pretty cool, right? And those are all like the instructions required to do my reenactment of the stream. And it's actually not too hard to go from this into a diagram. So this is a picture representing what we just did on stage, which was what our stream was doing. So to read it, we start with the black dot. You can see the stage names, by the way, on the left. So cat names at the top, then eat, then nap. We start with the black dot, and we just follow the arrows. So an arrow up is a pull, and an arrow down is an output. So we see over here, right, nap pulls on eat pulls on cat names, that outputs mal, and eat outputs mal with a can. We're also doing a few other things. We're drawing the side effect. So we're drawing what's printed, and we're doing that down at the bottom. Okay? So after eat gets mal, right, it's going to print mal with a can, and then it's going to output mal with a can. And similarly, nap is going to then output mal with a can and a box. Okay, so that's really cool. And that is effectively what aquascape does. So now, to show you what aquascape does, I actually have a live demo, which I've never done before, by the way. I've never done live demos, so let's hope they work. All right, so we have some code here using the aquascape library. So this is a library which just has that stage operator that you saw inside it. Ignore the fact that it's a snapshot dependency. You could actually just use like the actual dependency, but I've got a few improvements. And you don't need to worry too much about what this code is doing, except we do have these stage calls. Right, and then, oh wait, what do I do? And then when I run it just with the Scala command. This file is called cat livescape. Did you know the Scala command can just run Scala files like this? It's cool, right? Okay, and it's going to tell me to update dependencies. It's going to run the stream. So it's printing mal with the can and popcorn with the can. And it finished. And then in this directory, I now have this image. Yay! Which is the thing you just saw in the slides. So I've generated this, right? I generated this just using some code. All right. Okay. We're pretty close, right, aren't we? We're pretty close to what we want. We have a diagram, right? It looked nice. Maybe it could have looked nicer, but I'm not a designer, right? But it's not quite as friendly as the things that we saw, right? The marble diagrams. Because with the marble diagrams, I mean, we could go and we could play around with them in our browser, right? The thing is that that's where some languages like JavaScript, they have the edge, don't they? Because, JavaScript just runs in browser. It runs in everybody's browser, regardless of whether they know about it, right? Which means that you can, if you're documenting a JavaScript library, just run the code. And you can't do that with Scala. Or can you? You can. Okay, so there is such a thing called Scala.js. And maybe it's not that widely used, but you can use it. But lots of libraries do compile to it. Okay, so what is Scala.js? What does that mean? So with Scala.js, you take your Scala code, right, a Scala file, and you kind of convert that to JavaScript. So you're sort of doing some compilation here, and you end up with a JavaScript file, a JavaScript version of what your code is. And then you can go and run that. Well, it's JavaScript, right? You can run it on Node, you can run it in a browser, you can do what you want with it. And so as long as your libraries in Scala also are compiled to JavaScript, like they have JavaScript binaries available, you can actually just use them in browser. And it turns out that FS2 is one of those libraries that is. So you can take FS2 and you can use it in browser. And aquascape, the code that we just saw for generating the stages, that's also compiled to JavaScript. Okay. Live demo number 2. Let's see if we can get this to work. So you don't need to just see the image. Let's see. So this is the command, right? So if I want to compile something to JavaScript, I have this command just using Scala. It's called power package. Oh, did you know that the Scala command can compile stuff to JavaScript? It's a cool feature. Okay, it's doing some stuff. All right, it's saying that it's written an app.js file. And if I go here, yeah, you can see that app.js file. Okay, and I should, I've got this file as well, which is an index.html file. This is just some HTML which embeds that app.js. Okay, and let's go and see if we can go to a browser. Hold on. I can't actually see my mouse. Can you guys see my mouse? Oh, that worked. Right. Let's go to, I've got something running, I think, on localhost 8000. Yeah, there we go. So this is that index.html file. And we have our image. Look. Cool. So this is generated, right? It's not a PNG, right? That was generated by the JavaScript running in my browser. That's really cool, right? But is it though? Right? Is that actually any better? Yes, okay, it's running in browser, but it's not interactive, right? It's part of the way there. Okay, so the cool thing now is that I can run my code in browser to generate a diagram, and I can actually run it on different inputs. So this is looking at a different operator, right? Now we're now looking at the take operator, and we're using this tool aquascape to try and describe what the take operator does. And you can see that this is now a function, right? Which will, when we call it, will produce a stream which will take a certain number of elements. And when that stream is run, it will generate a diagram. So now what we can do, just by compiling it to JavaScript, is that we can go and we can just plonk a little input box into our page and then regenerate our diagram. And in fact, you can go to the Aquascape website, which is zainabali.github.io/aquascape, and you can go and have a look at all sorts of different operators. Let's have a look at take. and you will see diagrams which are generated in your browser. And you can play with those diagrams like this. And okay, it's not maybe quite as friendly as the marble diagrams because I'm not very good at drawing pictures. But I mean, I think it's still pretty good. Okay. All right, so that's where the project is now. Where are my slides now? Here are my slides. Cool. There are some other really interesting features, by the way, which is that if we take a look at our page, if we take a look at the Aquascape website, you'll see that we're documenting time. And this page, if I refresh it, it loads straight away. It loads straight away, but if you actually have a look at these code examples, they've got sleeps in, right? We're sleeping for 1 second. We weren't sleeping for 1 second, were we? I mean, in the first version of Aquascape, you actually were sleeping for 1 second. So when you went to this page, if you had an example that was like 10 seconds long, you would just be waiting. So this actually uses some really cool stuff within the Scala type level ecosystem. It uses a different runtime to execute the code. So instead of executing the code and actually sleeping, it uses a mock runtime to mock time, which means that these diagrams can be generated instantly. Okay, so yeah. So that is where Aquascape is. It is currently on the website, on the Aquascape website. It is, there we go. There is a roadmap for including it in the official FS2 documentation, which means that when learning functional streams in Scala, you will not even need to know that this tool exists. You will just need to go to the documentation. You will see these diagrams, and then they will help you understand how streams work. And this is just for streams in Scala, but I actually think that you can kind of take the same mentality and you can apply it to many other libraries, just by thinking of different ways of explaining our code or diagramming our code, and also of explaining our code to people who don't necessarily have the setup, right? One of the things that is really important about this is that anyone can just go to their browser and run this. You know, you don't need to have Scala installed, right? You can be just looking at some Scala code online and wanting to understand it. Cool. Right, so, well, thank you very much, and I hope you enjoyed it. I would also encourage you to check out, as well as Aquascape, the book, right, which Hanma mentioned. There is a book on functional stream processing, which is actually based off of a workshop that I gave last year. So thank you to everybody who attended that workshop and for helping me polish up that content. The book has lots of cute cat pictures. You can try and recognize Mao, because one of them is him. And the other cats are all cats of contributors to the type level ecosystem. So